Dear students, in the previous sessions, we have discussed regarding the effects due to temperature, chemical, wear and erosion, and also with respect to the design. Now, in this session, we are going to discuss regarding what is the effects due to the construction errors on the serviceability and durability of the structures. So that we can discuss regarding the corrosion mechanism and also the effect of cover thickness and cracking. Okay. So in this particular session, after listening to this particular session, students can understand what is the effects of construction error on the durability and serviceability of the structure and how actually the corrosion mechanism will be there and what is the effects of cover thickness. Okay, so all these are very important topics. So let us discuss one by one. So first, let us discuss regarding the construction error. In the previous session, we have discussed regarding the design error. Now, in this session, we can discuss regarding the construction error. So, as the design error is important, similarly, the construction error is also very much important. That means for this, for the while construction of buildings, there should be minimum errors. Okay, it is not possible to do the 100% satisfaction for the design conditions in the field. Some of the changes will be there in the site conditions, but the construction error should be avoided as much as possible, which influence the durability and the serviceability of the structure. Just let us go one by one. That is adding water to concrete, improper alignment of formwork, improper consolidation, improper curing, improper location of steel reinforcement, premature removal of formwork, settling of concrete, next settling of subgrade, vibration of freshly placed concrete, improper finishing of flat work, adding water to the surface, timing of finishing, adding cement to the surface, use of tamper, joint. So these are some of the general construction error which we are doing. So adding of water to the concrete, we know the excess water, if we add the excess water to the concrete, we know what happens, the permeability increases automatically, the strength of the concrete will also reduce. Okay, that is the one construction error we have to avoid. Next, improper alignment of formwork. So according to the structural shuttering drawing, we have to put the formworks. Otherwise, if we are doing the improper element, what happens? There will be variation in the, for example, structural elements, which affects the serviceability. Next, improper consolidation. That means we have to do the proper compaction of the concrete structural elements. Otherwise, we know what is the actual problem we face with respect to the improper compaction or less compaction. That means the porous will be generated, the water will sit in there, automatically what happens, that will reacts with the that may corrosion will take place and some other chemical actions, chemical causes will also increases. Next, improper curing. We know the curing is very important in the construction field. It is if we do the improper curing, what happens? There will be shrinkage cracks will develop automatically. The cracks will develop that may plastic shrinkage and ultimately the other type of shrinkage cracks will also develop, which affects the serviceability and durability. Next, improper location of reinforcing steel. If once the structural steel is issued to the field, what happens? The bar benders should place the steel location properly. That means the engineers has to be taken care such that the steel location should be proper according to the drawings. Next, premature removal of formworks. We know nowadays the to continue the work, what happens are to use the formwork materials. They were removing the formwork very shortly. That is for 6 days, 7 days, and 8 days. They were removing. So this is the meaning of premature removal. This should not be done. This is coming under the construction error. Next, vibration of freshly placed concrete. That means we have to do the fresh concrete. That means while casting, we have to do the proper vibration. Otherwise, compaction will be reduced. So next, adding water to the surface. This should not be done. Next, timing of finishing, adding cement to the surface. This we have discussed in the previous session. That is regarding what is the effect of adding of the cement to the surface to avoid the bleeding. Okay, that means to if the bleeding of the concrete is occurs, what happens? Some people will just they were putting some of the cement to the surface, which generates the shrinkage cracks. So uses of tamper instead of doing proper vibration, using only tampering, that is also will cause the compaction. These are all coming under the construction error. This an engineer or a builder or developer should take care with respect to the construction error. So this construction error will affect the influence, will affect the serviceability and also the durability. Next, let us go to the corrosion of reinforcement in concrete. You know, this we have studied in the third semester or fourth semester concrete technology. Just we are going once again the regarding reinforcement in concrete. You know, this is also one of the very important topic with respect to the retrofitting and rehabilitation of structures. Just let us see the corrosion process of reinforcement embedded in concrete has two distinct periods, namely. Okay, that means in the previous session we have discussed what is the definition of corrosion and what exactly the corrosion is. Okay, now in this session we are discussing different corrosion protection techniques and also the corrosion mechanism. So the corrosion we are having two different periods, that is initiation period and propagation period. So in the name is discussing that one initiation. What is the meaning of initiation period? So this is the time taken to initiate the corrosion, which can be caused either by ingress of carbon dioxide or chloride ions. That means the initiation period is nothing but the time taken to initiate the corrosion process. Okay, that should be more. Okay, what happens? The corrosion period is more, initiation period is more, the corrosion initiation will be late. So we are in the safer side. That means the if the initiation period is more, that means the carbon dioxide and chloride ions will be. Next, coming to the propagation period during which begins at the moment of depassivation and involves the propagation of corrosion at a significant rate until a final state is reached. That means we know what is the meaning of passivation. That means propagation period is nothing but the passivating layer, what we are calling as a protective layer for the reinforcement, is destroys and the corrosion will initiates, corrosion will starts. For that we are calling as propagation period, and ultimately till the, the destroy of the passivation layer and up to reach its maximum stage, that is to the rust. Up to that period we are calling as propagation period. Next, corrosion of steel is an electrochemical process where there is a difference in electrical potential along the reinforcement in concrete and electrochemical cell is set up. We know the corrosion technique is nothing but the electrochemical process. The corrosion mechanism is the electrochemical process that we can see in the next coming up slides. So what happens actually, where there is a electrical difference, that means the positive charge and negative charge. We know the steel is having one part as anode and another part as the cathode. Okay, that is one side it is positively charged and the other side is negatively charged. If it is connected by the electrolyte in the form of pore water and in the hardened cement paste. So this is the because of proper not doing proper compaction. For example, if you do the proper compaction, what happens? Pore water will be reduced. So thereby the positive and negative charges will not come together. So we have to do the proper compaction, what we have studied in the construction errors. Okay. Next, the positively charged ferrous ions Fe plus at the anode pass into the solution, where negatively charged free ions pass through the steel into cathode. Okay, where they are observed and the constituents of the electrolyte and combine the water and oxygen to form hydroxyl ions. Okay, this is nothing but the positively charged ferrous and negatively charged free electrons, okay, which pass through the steel into cathode, and with the combination of the oxygen and water, if the water and oxygen is not available there, there will be no corrosion. Okay, so after that ultimately it forms the hydroxyl ions. Okay, there is the reverse portion of the production of the steel. Okay, you can see the chemical equations here, how actually the cathode and anode will be developed. So this is the pictorial representation of the corrosion mechanism. See, you can observe here, this is a steel rod, this side it is cathode, this side it is anode. Okay, so free ions, okay, this is free ions, that is negatively charged free ions is passes into the anode, and on other side it is from anode to the cathode, which generates 2 FeOH2. This is the rust actually. Okay, this is regarding the mechanism of the corrosion of steel. Next, let us discuss regarding the effects of cover thickness. We know the IS4 physics clearly mentioned how actually the cover thickness will be. For a particular type of exposure, the cover thickness is fixed. Okay. So in reinforced concrete structures, sufficient cover of concrete has to be provided to avoid exposure of reinforcement to aggressive environmental conditions and consequent rusting and deterioration of the cross-sectional area in the structural elements. We know the cover thickness is very much important. That means it avoids the exposure of the reinforcement to the environment. Okay. So that means to avoid the ingress of the oxygen or carbon dioxide or moisture. So proper cover thickness is very much important. If we give the proper thickness of the cover, the almost 75% deterioration of the structures, that means causes because of the chemical causes will destroy. Okay, so we have to give the proper cover thickness. Next, according to IS 456, we are having for normal exposure a minimum 50 mm thickness, for moderate exposure 40 mm, for mild exposure 30 mm, and normal exposure we have to give at least 20 mm thickness. So this is regarding the thickness of the cover. This cover we have to be maintained. Now for the different structural elements, the IS 456 and also SP 16 is clearly mentioned. For example, for a beam, for what type of exposure we have to consider which one, and for the column we have to give minimum 40 millimeter of the cover. Like that we are having a specific cover thickness, so we have to follow that. Anyhow, in this session we have discussed regarding the construction error and corrosion mechanism, and also regarding the effects of cover thickness. So in the next session we can discuss regarding the corrosion resistant techniques. Okay, with this I am going to close this session. Thank you.